Hi, it's Mr. Tosh. We're going to take a look at the answers to the January 27th homework. So the first one is a question about social media websites and how the data is being stored. It's storing metadata about the time it was posted, the name of the user, and the names of the users who comment. Now, which of the following goals would it be more useful to analyze the data instead of the metadata? So watch that. When is it better to analyze the data instead of the metadata? The users who post messages more frequently, that's a check on the metadata. The time of day that the site is most active, this isn't correct because that's a check on the metadata. And this is analyzing the data, not the metadata. And this answer checks the metadata. Determine the topics that many users are posting about. That's something you're going to get out of the actual data, not out of the metadata, and that's why that's wrong. Determine which posts from a particular user received the greatest number of comments. That is somewhat useful, but topics are more useful. So that's really what it is. Now, this next question, program that is written, this is the one that talks about which of the following considerations are least likely to affect the ability of a program to process larger data sets. Most of you got it. How many program statements the program contains. That doesn't impact it. How long a program takes to run won't impact it. So techniques to process data do change as larger data sets increase. So larger data sets often take a longer time to process. And it's about least likely to affect the ability. So this one will impact it. This one won't. That's why. Now, this next one, an ISP is talking about an update to save web pages. Again, trick question. Which of the is least likely to occur? And I think the people who got these answers weren't looking at the question of least likely to occur. Websites that are not visited frequently may not suddenly be inaccessible. That's the least likely to occur. Storage requirements for the servers might increase. Those change all the time. Average response time for user requests might decrease. Again, it's something that's highly variable out there. So those are more likely to increase than suddenly a website just disappearing. Now, this next one, biotechs are tracking have collars to track wild animals, and the data they collect is time, date, and location. So they're collecting time, date, and location. A lot of us got this wrong, and a lot of us went to this answer. Does the animal travel in groups with other tracked animals? Here's the thing. Which of the following of questions about a particular animal could not be answered using only the data collected from the tracking collars? Okay. Does the animal travel in groups with other tracked animals? Or does the movement patterns vary according to the weather? Again, it's what could not be answered. This one can be answered because you're talking about other tracked animals. And we're asking about what cannot be answered. What cannot be answered is the weather. Why? Because we're not asking for any weather information. We have the other tracked animals, so we have that information. We don't have the weather information, and that's why that's right. Now, over here, this one got a little tricky because we forgot about the meaning of lossless. 4 of us kind of got it, 2 of us didn't. So let's take a look at that. What happens over here, if you look at the grayscale, and we're talking about changing this particular answer, is talking, well, let's look at the question. Which of the following describes a lossless transformation? Remember, lossless means it is exactly the same in both locations. Now, this one, creating a negative of the image and the negative is reversed, this is actually going to get you an exact copy right here. You haven't changed any of the values, so it's going to give you a lossless transformation. It's exactly the same size when it's transformed. Now here, if you're changing from colors to a shade of gray, you've significantly reduced the amount of data because you don't have any color data. It's grayscale, so it's just shades, so it's a lot less. Modifying part of the image by taking pixels in one part of the picture and copying the pixels in the other part of the picture. Again, you're duplicating it, you're reducing the amount of total data you need. This is going to transform. You're going to lose data doing this. You're going to lose data in this because you're taking color data out. Here you've copied data and transposed it, so you've taken data out. Here is the only time where you have not removed data. This one, boy, this was a real difficult one for you, so let's take a look at it. The trick with an example like this is you want to look at patterns. So as I go from, I'm adding zeros, and they're asking the question about this fictional 4th column. So what if I added another 0? So instead of going from 100 or 1,000 to 10,000, we're going from 10,000 to 100,000. We're adding another 0. Well, here we pretty much add a 0 each time. All right, here we're really only adding 100 hours each time we add 10 times as much. So deleting entries becomes more efficient. Searching through the data isn't a significant change. It goes up 50 hours every time you add a 0. So we can assume that over here we're going to be 400. We're going to assume that over here we're going to be 400. Over here we're going to be 2,000 for the backup. We go from an hour to 100 hours. Now we're going to go from 100 to, presumably, if we're adding 2 zeros, we're going to go up to 10,000 hours. So we have 200 becomes 2,000. This becomes 400. This becomes 400. This becomes 10,000. What is likely to take the longest amount of time? 10,000 hours is clearly the longest amount of time it's sorting data. Searching through data is only going to be 400 hours. It's not my biggest value. And backing up data, it's going to be 2,000 hours. Compared to 10,000 hours for sorting, it's not anywhere near it. So that's why that works out that way. Let's take a look at the next question. Most of us got this. One person didn't think that generating a list of criminal suspects given the data, this is one about analyzing the metadata, and the metadata was who, when the call was placed, and the phone numbers of both participants. That would give them a criminal suspects list because we're going to know who the criminal's talking to. So 3 is still good. Number 1, determine whether a crawler frequently uses a specific word. That's not valid, but none of you thought it would be. You just missed that 3 was valid. That's the only thing you missed. 2 was also valid. You were correct. Now over here, this is a tricky one. You got to understand the nature of data compression. Data compression is only used for files being transmitted over the internet. It is useful for files being transmitted over the internet, but it's also useful as a storage device. If I'm archiving files on a gigantic server and I only need to pull them up. But it's wrong because there are trade-offs. And the thing about trade-offs, while it might be useful to archive old data, if I'm retrieving archived data, it may take longer than retrieving data that is not archived. So there are trade-offs involved in that. Whereas if I'm talking about data compression being only useful in one context, that's simply not true. I can compress data in a server and have a good reason for it. It's just that I pay for it. Now, over here, a student is recording a song on her computer. She saves a copy to her computer, and she noticed that the saved copy is of lower sound quality. Which of the following could be an explanation? Now, the incorrect answer, some information is lost every time a file is saved from one location to another location. That's just not true. You have lossless ways of saving files, and you have lossy ways of saving files. However, she was obviously using some kind of a saving technology, a compression technology that lost quality. It's a lossy technology that she's using, and that's the most likely explanation. The song was saved using fewer bits per second than the original song. In other words, lossy technology. To get this, you want to go review in the textbook where it talks about lossless versus lossy saving technology. That's in unit 2 or 3, I'm not sure. Let's go back and check. Now, this one, retailer. Now here's the thing. Retailer is saving records, the identification number, the type, selling price, size, color, and quantity. This one we kind of went for a walk. About half of us got it wrong. The type of footwear that is most popular amongst adults. Well, if I'm going to save that information, I better have the purchaser's age. I don't ever collect the age of the purchaser. What colors are more popular among women? Well, I do collect the color, but I don't collect the gender. So I don't know who's buying what. I don't know that. I can't connect that a color is popular amongst women. I can collect the information as to whether a color is popular, but not whether it's popular amongst women. Down here, which items are listed in the database that are currently not in the store? Absolutely. Whatever I've got in my database, and I can check their inventory against their store, and it'll give me a dead-on number on that. Good. We're getting close to the end here. This one. Larger data set contains information about computer science majors. The data set contains gender, state in which the student attended college, and grade point average. Now, most of us got it. How many states have a higher percentage of female computer science majors? We've got gender, and we've got the state. So we've got state and we've got gender. We're good. Now, right here, do students majoring in computer science tend to have a higher grade point average than students majoring in other subjects? Why does this not work? Well, we don't have any information on students majoring in other subjects. That's why this answer is wrong. We never do figure out what other subjects we have data on, so we're not collecting that data. Now, That is all of them. Thank you for watching. I know it was a long video, but I hope that helped. Thanks for watching.